Hey guys, Mr. Burns here with your video for Lesson 3-GT Scientific Notation. Scientific notation is a way that scientists easily handle very large or very small numbers. One example can be the approximate distance to the Sun from each planet in our solar system. For example, Mercury is like 36 million miles from the Sun. Well, that's a pretty big number, so in scientific notation that would be rewritten as 3.6 times 10 to the 7th power. Another example would be something like Jupiter. Jupiter is 484 million miles from the Sun. If you were handling that number, you could rewrite it in scientific notation, so it would be rewritten as 4.84 times 10 to the 8th power, and so on. Approximate distances, such as these, are written in both standard notation and scientific notation. Again, it is useful to write numbers in scientific notation when they are very large or very small. Scientific notation uses powers of 10 since numbers are in a base 10 system. Each time you multiply a decimal by 10, you move the decimal point one place to the right. Each time you divide by 10, the decimal point moves one place to the left. So when you're moving the decimal point either to the right or to the left, the only thing that changes is the decimal point, not any of the digits. And that's one of the beauties of using the scientific notation and either multiplying by 10 or dividing by 10. It's the only thing that changes is the decimal place, not the digits. Scientific notation is an exponential expression using a power of 10 where the number you are using is less than 10, but the absolute value of that same number is greater than or equal to 1, and where p is an integer. A lot of this sounds really confusing, but once we get into the worksheet, you'll find out how easy it actually is. There are times when numbers are written in scientific notation and you want to convert them to standard notation. You must first expand the number by multiplying by the given power of 10. The exponent on the 10 gives the number of digits the decimal point is moved left or to the right. So again, when you want to deal with numbers in scientific notation, or compare them, you have to convert them to standard notation, which means not in scientific notation. Alright? So anyways. So again, if you need to compare numbers in scientific and standard notation, first you have to convert each number to standard notation, and then compare the numbers when asked or as asked. Alright, let's go ahead and just dive right into this worksheet, and hopefully this will make a lot more sense to you once we get into it. Your instruction for number 1, it says scientific notation is an expression in the form of n times 10 to the p power. N is a number whose absolute value is between 1 and 10. And p must be an integer. Alright, so let's check out the other problems. Okay, your instructions for numbers 3 through 10 are to write each large or small number in scientific notation. The one thing that I forgot to mention is when you start off with a really, really small number, such as number 3, or number 6, or number 7, or number 10, your exponent is always going to be negative when you rewrite it in scientific notation. If you have large numbers, when you begin with large numbers, such as on number 4, 5, 8, and 9, so when you start off with really big numbers, your exponent is going to be a positive number. So here we go with number 3. On number 3, we have 52 hundred thousandths. And which direction do we have to move the decimal in order to make this number bigger than 1 but less than 10? And we have to move it to the right. So since we start off with a really small number, our exponent is going to be negative. So I'm going to go ahead and put that sign right there for right now. Negative sign. Do this. Negative. So let's count 1, 2, 3, 4. So we go 5.2. That number is more than 1 but less than 10. And how many times did we move it? We had to move it 4 times to the right. So this is an expanded form, or an exponential form. Let's take a look at number 4. On number 4 we have 8,300. So we have a really big number, so our exponent is going to be positive. And then I'm going to move the decimal to the left 1, 2, 3 spots. So I come up with a new number of 8.3. That number is more than 1, less than 10, so we're good to go. And how many times did I have to move the decimal to the left? I had to move it to the left 1, 2, 3 times. So it's times 10 to the third power. There we go. So number 3, when I rewrite it in scientific notation, it's 5.2 times 10 to the negative fourth power. And for number 4, I have 8.3 times 10 to the third power. All right, let's take a look at number 5. On number 5, we have 7 million, so it's a really big number. So our exponent is going to be positive. How many times do I have to move the decimal to the left in order to make it more than 1 but less than 10? Let's see, we got 1, 2, 3, 4, 5, 6. So we've got 7.0 times 10 to the sixth power. Now, do we have to put the 0 there? No, we don't, but if you want to, that's okay. I won't mark it wrong. So on number 5, when we rewrite this in scientific notation, we have 7 times 10 to the sixth power. All right, number 6. On number 6, we have 41 tenths, hundreds, thousands, 10 thousandths. We have 41 10 thousandths. That's a really small number. So my exponent is going to be negative. And how many times do I move the decimal to the right in order to get a number that's bigger than 1 but less than 10? I have to move it 1, 2, 3 times. So my final answer in scientific notation is 4.1 times 10 to the 1, 2, 3, negative 3 power. All right, let's take a look at number 7. On number 7, we have 9, let's see, tenths, hundreds, thousands, 10 thousandths, 100 thousandths, millionths. We have 9 millionths. That's really small. So it's going to be some number times 10 to the what power? So since it's really small, it's going to be a negative exponent. So let's count. Let's move the decimal to the right until we come up with a number that has more than 1 but less than 10. So you got 1, 2, 3, 4, 5, 6. So I had to move it 6 times. So my exponent is negative 6. And my new number is 9. So it's 9 times 10 to the negative sixth power. And that is my final answer when it is rewritten in scientific notation. On number 8, we've got 82,000. So that's going to be some number times power of 10. And since we started off with a really big number, our exponent is going to be positive. And let's move the decimal to the left until we come up with a number that is more than 1 but less than 10. So we've got 1, 2, 3, 4. So my new number is 8.2 times 10 to the positive 4 power. And there you have it. Number 9. On number 9, we've got 190. And that's going to equal, so we got some number times a power of 10 to what exponent? It's going to be positive because we're starting off with a big number. So we're going to move the decimal to the left to make this number larger than 1 but less than 10. And how many times do we move it? 1, 2, positive 2. And my new number is going to be 1.9 times 10 to the second power. Sound good? Here we go. Number 10. On number 10, we have 7 tenths, hundreds, thousandths. So 7 thousandths. So that's a small number. So it's going to be some number times 10 to the what power? It's negative because it's a really small number to start with. So let's move the decimal to the right until we come up with a number that's more than 1 less than 10. 1, 2, 3. So we moved it 3 times. And our final answer is 7 times 10 to the negative third power. And there you got it. Let's take a look at the next part. Okay, your instructions for numbers 11 through 16 says write the following numbers in standard form. Okay, so again, if you have a positive exponent, you're going to move your decimal point to the right. If you have a negative exponent, you're going to move your decimal to the left. So here we go with number 11. You've got 3.8 times 10 to the third power. Let's start off with what we know. We got 3.8 times 10 to the third. So the exponent 3 tells me I'm going to move my decimal. The positive 3 tells me I'm going to move my decimal to the right 3 times. So 1, 2, 3. Add my zeros and rewrite my final answer, which is 3,800. And there you have it. Number 12, you've got 7.1 times 10 to the negative 2 power. So let's take a look at my exponent. It's negative, so I'm going to move to the left. How many times? 2. So let's start off with what we know. We've got 7.1. And I'm going to move my decimal 2 spots to that left. 1, 2. Put my decimal, add my 0 if I need to. And my final answer is 0.071. And there you have it. On to number 13. On number 13, you've got 4 times 10 to the third power. So I've got a positive exponent, so I'm going to move my decimal to the right. Let's start off with what I know. I've got 4, and I'm going to move my decimal 3 spots to the right. So 1, 2, 3, add my zeros, and rewrite this. So my final answer is 4,000. Alrighty. Number 14. On number 14, I have a negative exponent, so I'm going to move my decimal to the left. How many times? 2 in this case. So let's start with what I know. I've got 3. There's my decimal point. I'm going to move 2 spots to the left, so 1, 2, and put my decimal and add my 0. And my final answer is going to be 0.03. Now you think to yourself, hey, Mr. Burns, do I have to put the 0 in front of the decimal? No, you do not. But when you put a 0 in front of the decimal, it really makes that decimal point pop out. Okay? Anyways, number 15. On number 15, we've got 9.28 times 10 to the 5th power. I have a positive exponent, so I'm going to move my decimal to the right. How many times? 5 in this case. So again, let's start off with what I know. I've got 9.28, and I'm going to move 5 decimal places to the right. So I got 1, 2, 3, 4, 5, and add my zeros if I need to. And my final answer is 928,000. All right, number 16. On number 16, I've got 5.15 times 10 to the negative 4th power. That negative 4 tells me I'm going to move my decimal 4 spots to the left in my final answer. So again, let's start off with what I know. 5.15, and I'm going to move my decimal 4 spots to the left. So 1, 2, 3, 4. Put my decimal and add my zeros if I need to. Get rid of my equal sign there. So 1, 2, 3. 1, 2, 3, 4. Yep. And my final answer is 0.000515. And there you have it. Let's go to the back side. Okay, on the back side, for numbers 17 through 20, we've got a bunch of story problems here. So on number 17, it says, a movie had a budget of $59 million. Write this number in scientific notation. So here we go. Let's rewrite it. Let's set it up. So we got 59 million. Okay, that's a really big number. So I'm going to move my decimal to the left until I come up with a number that is more than 1 but less than 10. So it's going to be some number times the power of 10. And let's count up how many zeros, or how many times I have to move the decimal to the left. 1, 2, 3, 4, 5, 6, 7. So my new number is 5.9 times 10 to the what power? 7th power. And it is positive because the original number is really big. All right. Number 18. In 18, it says, in 2008, Idaho's population could be approximated by 1.5 times 10 to the 6th power. Write this in standard notation. So let's start off with what we know. We've got 1.5 times 10 to the 6th power. Again, look at the exponent. The exponent is positive, so I'm going to move my decimal to the right because when I multiply by positive bases of 10, okay, in this case I'm going to multiply by the base of 10 6 times, which moves my decimal to the right. Sorry. So let's go ahead and rewrite this. So 1 times 5, or 1 times 5, 1.5, it's getting late. And I'm going to move my decimal to the right 6 times. Why? Because I'm going to multiply by 10 6 times. So 1, 2, 3, 4, 5, 6, and add my zeros. And my final answer is 1,500,000. And that's the population of Idaho. All right, number 19. Alrighty, on number 19 it says, Hank hauled 6.7 times 10 to the 3rd power pounds of rocks, and Nyson hauled 2.4 times 10 to the 4th pounds of rocks. Who hauled more rocks? So when you're comparing numbers that are written in scientific notation, you first must convert it back to standard notation before you compare. So let's go ahead and do that here for Hank, shall we? So on Hank, we got 6.7 times 10 to the third power. Got my little Trey Crowder going on here. All right, since the exponent's positive, when we rewrite this in standard notation, I'm going to move the decimal 3 spots to the right. So let's start off with what we know, shall we? So we've got 6.7, and we're going to move it 3 spots to the right. 1, 2, 3, and add the zeros if necessary. So Hank hauled a grand total of 6,700 pounds of rock. That's a lot of rock if you ask me. Alright, now let's move on to Nyson. So in Nyson we've got 2.4 times 10 to the 4th power. Now since we got a positive exponent, that means we're going to move it 4 spots to the right. So again, let's start off with what we know, shall we? Got 2.4. We're going to move it 4 spots. Here we go. 1, 2, 3, 4. And add the zeros if necessary. Now here we go. When we rewrite Nyson's pounds of rocks, we've got 24,000 pounds. Now you tell me who you think hauled more rocks. Was it Hank or was it Nyson? I doggone guarantee you that it was Nyson who hauled more rocks. So Nyson. There you have her. Alright, down to number 20. So here we go on number 20. It says list the following numbers in order from least to greatest. So when we're comparing these numbers, again, we have to convert them from scientific notation into standard notation. So let's take the first number. The first number is 8.3 times 10 to the negative 2 power. Now, since it's a negative exponent, we're going to move the decimal to the left. How many spots? 2. So let's go ahead and do that. So let's start off with what we know. We got 8.3 times 10 to the negative 2 power. We got 8.2 and, 8.3. Give them more space here. 8.3, and we're going to move it 2 spots to the left. 1, 2, and add the 0. So our final answer there is going to be 0.083. Alright, next number, 0.06. It is already written in standard notation, so we shall leave it. 0.06. Next number is 0.095. That is already, again, that is written in standard notation, so let's leave that alone as well. So we've got 0.095. Now let's take 7.2 times 10 to the negative 3rd power. We have negative exponents. So when we rewrite this in standard notation, we're going to move it 3 spots to the left. Here we go. So let's start off with what we know. So we've got 7.2 times 10 to the negative 3rd power equals, let's start off with what we know, 7.2 and 3 spots to the left. 1, 2, 3, and add the zeros, shall we? 1 and 2. And our final answer there is going to be 0.0072. Alrighty, since we're comparing decimals, one thing you might want to do is stack them and line up the decimal point. I'm going to go ahead and do this in green. So we've got 0.083, 0.06, 0.095, and 0.0072. Now, out of these three, which is the smallest? Let's start off with the tens column. Those are all zeros, so we can't tell which one is the smallest. Let's move to the hundreds column, and we've got 8, 6, 9, and 0. Out of 8, 6, 9, and 0, which one is the smallest? That is 0. So that decimal is going to go first over here where it says least. So our smallest decimal is 0.0072. We're done with that decimal, so let's cross it out. Goodbye. Again, let us take a look at the tenths place. We cannot tell which one's the smallest, so let's go to the hundredths place. In the hundredths place, you have 8, 6, and 9. Out of those three options, which one is the smallest? Obviously the 6. So that is going to be the next number, 0.06. Now that we are done with that number, let's go ahead and cross it out and leave it alone. Out of the last two remaining digits, which one is smaller in the hundredths place, 8 or 9? Obviously 8, so that goes next, 0.083, which leaves us with the largest decimal, which is 0.095. So 0.095. All right, that is it, students. Let's go ahead and get out a piece of paper, a pencil, and a calculator, and let us prepare for tonight's homework assignment. Good job.